Hello, you're welcome back. Okay, so we're gonna be looking at the different combination of resistors, okay, or the different connection of resistors. Now, already we know that a resistor is a device that actually opposes the flow of current, okay, and we have some devices that is constructed as an electrical component that their duty is to oppose current, and um, and we call them resistors. They are of different value and their SI unit is ohms, okay? Now, depending on the amount of opposition that you are looking for, you might need more than just one resistor, okay, in a particular circuit. And those resistors can be connected in a particular way. Either they are connected in a series or they are connected in parallel, okay? Or you can connect it in a more complex form, which actually include a combination of series parallel. So now let's look at this different combination. Okay, so I'm going to start with resistors in series. All right, now this particular circuit diagram shows three resistors connected in series. Okay, so resistors are connected in series when they are connected end to end. All right, just one end of one, okay, or let's say the one terminal is connected to okay, let me put it this way. The positive terminal of one, let's say we divide them into positive and negative. Let's say this negative and this positive. Then this is gonna be negative, this positive, this negative, this positive. Okay. So we'll talk about the terminal of a resistor when we are going to discuss more on the terminals of resistors when we treat Kirchhoff law. But this is just a typical connection of series. Okay, this is a series connection, and one of the things that actually make you to know that resistors are connected in series is that the same piece of wire, okay, connect them. There is no branch. All right, that simply means that the current that flows through those resistors flows without branching. All right, of course, you know that a branch is actually established when there are two components, all right, um, connected parallel when in the path of flow of current. So now, this is just a typical example of resistors connected in series, and there are three of them. So the same current actually flows through the resistor. So these are the characteristics of resistors connected in parallel, okay? So the current that flows through the resistor is the same. Why? Because there's no branch. Number two, the voltage across each resistor actually varies. The voltage across each resistor varies, okay? And of course, the power is additive. So what does that simply mean? It simply means that across this resistor R1, the voltage across it is V1, which actually varies with voltage across R2, and according V2, it also varies with the voltage across R3, according V3. The same thing, and of course, this particular voltage is additive. You can add them, all right? So the total voltage is going to be V1 plus V2 plus V3, the same with their power. The power that R1 will dissipate plus the power that R2, okay, will dissipate plus the power that R3 will dissipate can be added to give the total power that the three resistors can dissipate, all right? So now, so as I said, the voltage varies. So each of these resistors will take up a portion of the supply voltage. The supply voltage is V, all right? Okay, let me call it V total, VT. The supply voltage is VT. So each of them will take up a portion of the supply voltage because this supply voltage will divide among V1, V2, and V3, okay? And they are going to actually divide this supply voltage in ratios depending on their resistance. So the one with the highest resistance will actually take more voltage than the one with the lowest resistance. Okay, so now we're going to actually get um, the formula for the equivalent resistance or the total resistance. Okay, when resistors are connected in series, how do you get the total resistance? How do you combine the resistance to get the total or the equivalent resistance. And that's exactly what I want to derive now. As we already know, when resistors are connected in series, their voltage actually varies. Okay, so the total voltage across the three resistors is going to be equal to the voltage across resistor 1 plus the voltage across resistor 2 plus the voltage across resistor 3. So from Ohm's law, we know that voltage is equal to current times R. So for V total, I'm going to have current multiplied by the total resistance. That's what I'm looking for. Then for V1, that's going to be current multiplied by the resistance R1. Then plus for V2, that's going to be current multiplied by resistance R2. For V3, current multiplied by resistance R3. Okay, so from what I have here, I have RT, the total resistance. Now, since the current has, you see me using, I use I for, okay, throughout the as a constant value for these three resistors, because the current, as we already said, is the same current that flows through the three resistors. Why? Because they are connected in series. Okay, so I have to factorize that current out. Then I open a bracket. I'm gonna have R1 plus R2, then plus R3. So current cancels current. So that I have that the total resistance now is going to be equal to R1 plus R2 plus R3. As simple as that. So we simply means that anytime resistors are connected in series and you are being asked to find the equivalent resistance for the entire resistors, okay, you just add them. For example, if R1 here is 2 ohms and R2 is 2 ohms, R3 is 2 ohms. So if you are being asked to find the total resistance, that's going to be equal to 2 plus 2, then plus 2, which of course will give me 6 ohm. The same thing happen with their power. Let's say if R1 consume 2 watt, R2 consume 2 watt, R3 consume 2 watt. So the total power three of them will consume is going to be equal to 2 plus 2 plus 2, which of course is going to be 6 watt. Okay, so I hope that is well understood. Now we are going to solve some questions before we now look at how we can get the voltage. We're going to solve some questions before we now evaluate how we get the individual voltage across each resistor. All right, so I'll clean up, then I pick some question. Okay, here we go. I have a problem here. Okay, so I bring it up to the screen and we'll do justice to it. Okay, so this question. Two resistors, 30 ohm, 25 ohm, 45 ohm are connected in series across 200 volts. Calculate their total resistance. Okay, solution. So since they are connected in series, their total resistance, okay, that's the I part of the question. Their total resistance is going to be equal to 30, of course, plus 25 plus 45. Okay, so of course, what's that? That should give me, this is 60, right? Plus 30, that's 90. So the total resistance is 90 ohm. The current, of course, the current. So from Ohm's law, we know that for me to get current is going to be equal to voltage divided by the resistance. So that current passing through these three, remember the current is the same, okay? The current passing through these three resistors is going to be the voltage supplied to them divided by the total resistance. The voltage that supplies to those resistors is 200 volts. divided by the total resistance 90. Okay, so 200 divided by 90. So that's gonna be equal to 2.2 ampere. Okay, so the potential difference across each resistor. All right. So now this will now give, before I solve this question now, I will now have to introduce what is known as voltage divider of series connection. Okay, remember there are three resistors, okay, connected in series, and their resistance is in the ratio of R1 is to R2 is to R10. So they are going to divide their voltage, the supply voltage V, based on this ratio. Okay, in mathematics, you know how we actually divide a value based on ratio. So that means the voltage across V1 is going to be equal to the resistance, the voltage across R1, which I call is V1, okay? The voltage across R1, I call it V1. That's going to be the resistance R1 divided by the total resistance, okay? By the total resistance of, then multiply by the voltage that they are going to be sharing, that is V, okay? So that's the V total. The same thing happens with V2, R2 multiplied by the total voltage, multiplied by the total resistance, please pardon me, times the total voltage. All right, then the same happens with V3. V3 is going to be R3. The voltage R3 multiplied by the resistance R3 multiplied by total resistance, then times the total voltage. Okay, so let's get our values. So that means V1 is going to be equal to R1 is 30 ohms. That's going to be 30 divided by the total, which is 90, times the voltage, 200. Of course, 30 divided itself 1, divide 90, that should give me 3, right? So I'm having 200 divided by 3. So that's 66.7 volts, approximately. Okay, so across the voltage across 25, across R2, V2, okay, R2 is 25, total is 90, then times the voltage supplied. Okay, so this is going to be equal to 25 times 200, then divided by 90. So that's 55.6 approximately. So that is how we actually apply voltage divider. Okay, so that we can get the voltage or the potential difference across each resistor. So please take note of that. All right, so let's work on another question. So the question goes like this. Find the value of R in the circuit diagram given below. So these three resistors are connected in series and their voltage is 200 volts, okay? So that means the total resistance is going to be equal to 50 plus 10, then plus the R, which is the unknown. All right. So now I can solve this simply by getting to use the voltage divider. From what I have here, okay, so I meant to understand that for 50 ohms, the voltage across 50 ohms is 100 volts. Okay, so if the voltage across 50 ohm is 100 volts, all right, then I can also get the voltage across 10 ohms. I can find the voltage across 50 across 10. Then that way I will be able to subtract the total voltage from these two voltage. That will give me the voltage across the resistance R. Okay, so let's do that already. So using voltage divider, okay, so V1, the voltage across 50 ohm, of course, is 50 divided by the total resistance, okay, which is going to be equal to 50 plus 10 plus R, okay, that's the total resistance. And of course, we already know that the R is what we are looking for, the unknown. So the voltage across V1 is 100. So 100 all over 50. Then divided by 50 plus 10 is 60. 60 plus R. That way now I can cross multiply. So that I'll be able to get R. If I cross multiply 100 multiplied by 60, that gives me 6,000. Then plus 100 R. Alright, then equal to 50 times 1, that's going to be 50. So arranging this equation, I'm going to have okay. I made a mistake. I'm not done. This is the voltage divider. I've not multiplied by the supply voltage. Okay. I've not multiplied by the supply voltage. Remember, the voltage divider is okay. The voltage across 50 ohm is going to be equal to 50 ohm divided by the total resistance, then multiplied by the supply voltage. Okay, don't forget that. So don't forget that. So this 50, that was still times 200 that I didn't take note of. So in this case, now I'm gonna have 100 R. 50 times 200. That's gonna give me 4,000. Is that 4,000? 50 times that should be 50 times 200. Okay, please pardon me. 50 times 200 is 10,000, not 4,000. 10,000. Then I take the 6,000 to the other side. That's going to be minus 6,000. So invariably now my resistance R that I'm looking for is going to be equal to, if I subtract this, 10,000 minus 6,000 gives me 4,000. And of course divide by 100. So that gives me 40 ohms. Okay, so I hope that is well understood. Let's look at another question. Okay, so what do I have? A 100 watt 200 volt bulb is put in series with 60 watt bulb. Okay, so this is 100 watts, 60 watt, they are in series. And from what I see here, the voltage across the 100 watt is 200 volt. So the question is, what are we even looking for? What will be the current drawn? Since these two are in series, the 100 watt and 60 watt, they will have the same current. So the same current that is passing through the 100 watt, okay, is going to be the same current that's going to pass through the 60 watt. So how will I get the current passing through the 100 watt? Of course, you know that current, okay, with respect to power, is given as IV, right? So for 100, the power is 100 watt, equal to, and the current is what I'm looking for. The voltage across the 100 watt is 200 volt. So that means the current now passing through the 100 watt is going to be 100 divided by 200. So that's going to give me 0.5 ampere. So the same current is passing through the 60 watt, okay? So the current that is actually drawn is 0.5 ampere. That is the circuit current drawn. Okay, the question is, what will be the voltage across the 60 watt? So to get the voltage across the 60 watt, I need to get the resistance across the 60 watt, okay? And from what I was told, the voltage that was supplied, the supply voltage, okay? Okay, I wasn't given the voltage that was supplied. So as I read, okay, I can get this. For me to get the voltage across the 60 watt, I'll still apply the formula. The power across the 60 watt, let me call it P60, is going to be current times voltage, okay? So the power of the 60 watt is 60 watt, right? And the current passing through the 60 watt is still 0.5. Remember, it's a series connection, so the current is the same. All right, then multiply by the voltage across the 60 watt. So the voltage across the 60 watt is going to be equal to 60 divided by 0.5. So that's going to give 120 volts. So I hope that is well understood. All right, next question. Here we go. Okay, so this goes like this. An incandescent lamp is rated 110 volt, 1000 watt. Using suitable resistor, how can you operate this lamp on 220 volts? Okay, so invariably what they're looking for is the resistor that must be connected, okay? That's the question. So what I mean by using super, what is the suitable resistor that must be connected with this lamp so that it can operate? So we're looking for the resistor R. And you know that will be very easy for me to find the resistor R, because first I need to find the current passing through R. The current that's passing through R is still going to be the same current that is passing through the 100 watt. And you know how we get the current passing through the 100 watt, right? So let's use power. So the power of the 100 watt is going to be equal to the current of the 100 watt multiplied by the voltage. Okay, so this 100 watt can only draw 110 volts. So I'm going to have, of course, 100 watt, then multiply by the current times the voltage 110. Then divided by 110. So 100 divided by 110. Okay, 0.9 ampere approximately. So that's the current that's passing through the resistor R. So if that is the current that's passing through the resistor R, Okay, so we can use Ohm's law to get the resistance. According to Ohm's law, V is equal to IR. So the resistance R now is going to be equal to V divided by I. The supply voltage, the V is the supply voltage, that is 220 volts. Okay, no. I'm not going to use the supply voltage, okay? Because it is just the resistor R is just going to be the voltage across R alone, not the supply voltage. Okay? Just the voltage that is going across R alone. Okay? So how will I get the voltage that's going across R? Remember, the total voltage of the circuit is 220 volts. So this 220 volts will be divided among this, and already among the 100 watts. The 100 watt have already taken 110 volts. Okay? So invariably now, for me to get the voltage that is going across the resistor here, that's going to be equal to 220, the total voltage, then minus the voltage that have already been taken, which is 110. All right? So I can write that down. So I call that V2, right? So V2 is going to be equal to the total voltage minus the voltage across V1, right? Across 1000 watt. So that's going to be equal to 220 minus 110. That should give 110, right? Yes, it should still give 110. So that way now I can get the resistance now, which of course is going to be V2 divided by the current. So 110 divided by 0.9. Okay, so 110 divided by 0.9. So that's 122 ohms. 122 ohms. Okay, we proceed. All right, so I have another question, okay, that I would have to do justice to. So this one goes like this. The lamp in a set of declaration lights are connected in series. If there are 20 lamps and each lamp has a resistance of 25 ohm, calculate the total resistance, okay? So they are connected in series, you have to add them up. The total resistance is going to be equal to the sum of the 20 lamps. That's going to be 20 times, there are 20 lamps, right? And each of them is having a resistance of 25 ohm. So that's going to be 20 times 25. 20 times 25. So that's 500 ohm. So first, that's their total resistance. So calculate the total resistance of the set of the lamp. Hence, calculate the current taken from the supply of 230 volts. Okay, so that will be from Ohm's law. So the current taken from the total lamp is going to be equal to the voltage supply divided by the total resistance. So that's 230 230 volt divided by 500. 230 divided by 500. So 0.46. Okay, next question. Okay, better still, we will be looking at resistors connected in parallel, okay, before we continue our solution. All right, see you in the next video. Thank you.